Hey guys, welcome back to Chilifili, and in this video we're going to see the mathematics behind normal equation in linear regression. So first of all we need to know what is a normal equation. So normal equation is an analytic approach to linear regression with a least square cost function. We can directly find out the value of theta without using gradient descent. And if you guys have already watched my previous video, then you might have noticed that we tried to find out the value of theta, that is basically the slope and intercept of a regression line, or you can say the best fit line, by using the scikit-learn library and by building a function from scratch to calculate it. So here you can see it. Okay, here is the function to calculate the value of intercept and slope. So we built this our own function, and here we used scikit-learn library to calculate the value of such coefficients. Okay, here you can see it. Okay, so in this video we are going to see how we can find the coefficient values or the value of theta using matrices. So normal equation is used to find the slope and intercept or the theta values using matrices only. So here you can see that all of these are matrices or vectors, where x transpose, it is pronounced as x transpose and it is the inverse of it. And I've already made a video about how the calculation happen in matrices. So if you want to check it out, I will put the link in the description. Okay, so in this equation, theta is the hypothesis parameter that defines it the best, and x is the input feature values and y is the output feature values. Okay, so moving forward to the derivation of normal equation. Okay, first we have is a hypothesis function. So hypothesis function is a theta 0 x 0 plus theta 1 x1 up to theta n xn. So in simple linear regression, you might have noticed that we only have this two parameters here, or like two steps here, that is the theta 0 plus theta 1 x1. Here you can ignore the x0 because it is always 1. We have to consider it because we are going to multiply our matrices, and we cannot multiply our matrices if we don't have the same dimensions with it, or we cannot add it when we don't have same dimensions as we need. Okay, so here the value of x0 will always be 1. Okay, so moving forward, the second one is we have vector theta, which holds the parameters from theta 0 to theta n, and it is a column vector, of course. And I have all this description of various type of matrices and its operation on my previous video. So if you want to check it out, I will put the link in the description. The next one is the vector x, that is also a column vector that holds the x coordinate of our data points. Okay, so the next point is the dot product between theta and x. So if you want to get this equation, then you have to transpose this matrix, that is transpose the theta matrix and then multiply it with our x matrix. Okay, so moving forward, so this will give us our main hypothesis function, that is this. Okay, so the next one is the cost function, and as we previously saw that we are going to use the least square cost function here. Okay, so the least square cost function is nothing but here as of theta of xi is the predicted value by our regression line, and yi is the actual output value, and we are going to sum it, or we are going to find the mean of it. So sorry, we are going to find the mean of its square, so it is the mean squared error function. Okay, so here is xi is the input value, and m is the number of training instances, or you can say the number of data points, and n is the number of data features, or we can say the columns, and yi is the expected result for the ith instance. Okay, so I think this is pretty easy to understand. Now moving forward to the sixth point, that is representing the cost function in a vector form. So here we are going to use matrices to find our coefficient values. So we have to first put it in a matrices and do some simplifications. Okay, so here we are going to convert this in our vector form, and here we are ignoring the 1 upon 2m here because it is not going to make any difference in our derivation. Okay, so here we can say that we just wrote it in a matrix form instead of this summation form. Okay, so here h of theta xi, it goes from 1 to m, and this also goes from 1 to m, so there is nothing new here. Okay, so instead of h of theta x, we can write the theta transpose into x, because that is our main function. Okay, here you can see it in point number 4. H of theta is equal to theta transpose into x, and h of theta is our main hypothesis function that is written here. Okay, so instead of h of theta x, we can write theta transpose into x. That will result the same. Okay, so instead of theta transpose x0, we can actually write our main function, that is theta 0 x0 plus theta 0 x1 plus up to plus theta n xn, and we can do it for all of our rows. Okay, and here is the y value. Okay, so moving forward to the next point, here xj of I equals to the value of jth feature in I training example. Okay, so here the I value is the number of rows here, and j is the number of column here, you can say it. Okay, so moving forward to the next point, that is we can also reduce this cost function to x theta minus y. Okay, so this is pretty easy to understand from it. Okay, so our cost function has a square in it, as you can see here. Where is our cost function? Here is our cost function. It has a square in here. But if you just multiply the same matrix, then it will not give us the square of each number. So we have to first find the transpose of the matrix that we are going to do here, and then we are going to multiply it. And I've explained all this in my previous video if you want to understand it very better. And okay, here I'm going to show you how we did it. Let me quickly grab it. This is the inverse, and okay, here is how we square each of this number. Here you can see that the square of each number is 1 square plus 2 square plus 3 square equals to 14, and if we want to get the sum of each number square, then we have to first convert it to its transpose, and we have to multiply it with itself. Okay, so here you can see that the answer is 14, and our original answer was also 14. Okay, so here we are going to do the same thing. Here we first converted it to its transpose and then multiplied by itself, and now we are going to ignore this 1 upon 2m because it is not going to make any difference in our derivation. Okay, the next thing is we give the transpose value to each of its element, so I think it's pretty easy to understand. Then we multiplied each of this element with each other, like x theta transpose into x theta and x theta transpose into y, and so on. Okay, so now the 11th point is the in above equation, it means in this equation the second and third terms are like the exactly same, and so we can add it. Here you can see that here is x theta transpose into y, and here is y transpose into x theta. So the question is how these terms are same. So I've explained it in my this video, so we are going to quickly get it. Okay, okay, here it is. It only works when a and b are vectors. Then we can say that a transpose b equals to b transpose a, and I have the complete derivation here. As you can see, it is very pretty easy to understand. Okay, so here we can say this is a and this is b. Then a transpose b equals to b transpose a, so we can add it. Okay, so now we have total three parts, or what do we say, three elements in our cost function j, and here we have distributed the transpose value, so we have to reverse the order of multiplication. Okay, and if you want to check it out, then it is all in my this blog or in my previous video, and I will put the link in the description for my blog if you want to read the article. Okay, no, so now our ultimate goal is to minimize the cost function. So we are going to find the derivatives and find the derivatives and give its value equals to 0, so it will give us the minimum value, or so it will give us minimum cost ultimately. Okay, so first we are going to find the derivative of this second, then we are going to find the derivative of this first function, and then this last function. Okay, so our second element is the 2x theta transpose into y. So here is 2 and here is our x matrix and here is our theta vector, and we are going to transpose it, and here is our y vector. I think it is easy to see here. Okay, so now we are going to multiply it. So how the multiplication occurs is we take the first row and multiply it with the first column. So x11 theta 1 plus x12 theta 2 plus up to plus x1 and theta n. Then the same thing for each rows here. Okay, you can see it here. Okay, so now what we are going to do is we are going to transpose this matrix and multiply it with our y vector. So you can see here, here was 2, so I've written 2 here, and this is x11 theta 1 plus up to plus x1 and theta n into y1. So this is first row into this is a first column. Okay, so I think this is easy to understand. Okay, so now we are going to simplify this equation a little bit more. Okay, so here we can say that we are going to go from row 1 to m, since we have m number of rows here and n number of columns here. So we are going to add it from row number 1 to row number m, and okay, so after then we are going to add the values like this is, suppose we start from r equals to 1, then this will be x11 into theta 1 plus up to plus x1n into theta n. So this is the first row basically, and we are going to do the same for the n number of rows. Okay, so we can simplify it a little bit more. So the y values are for each of the rows, and now we are going to add the column values also. So this is xrc into theta c. So here c is the value of columns. So here you can see if we take 1 1 for both rows and column, then it will give us the first element, that is x11 theta 1. And if you take n as a number of column and 1 is number of rows, then it will give us x1n into theta n. So it will ultimately give us this element. Okay, so moving ahead to find the partial derivatives. Okay, so this is our function p, and we are going to find the partial derivative with respect to theta 1 and theta 2 and up to theta n. Okay, so finding the partial derivative is simple. Okay, so first we are going to take this value, and we are going to find the partial derivative with respect to theta 1. Okay, okay, so here you can see that our p value is okay, so here we are going to find the partial derivative of p with respect to theta 1. So here is our p function. So if we find the partial derivative with respect to theta 1, then all the other elements like theta n or theta 2 will got cancelled out, and we will be left with this 2 will always be there. So 2x11 theta 1 plus 2 into x21 theta 1 plus up to plus 2 into xm1 theta 1, or this term, or we can say the first element of each of this row. So this column will be here in our partial derivative, and for finding the partial derivative with respect to theta 2, we will have the second column with us, that will be here, and for finding the partial derivative with respect to theta n, then we will only have this row with us. Okay, so I think this is easy to understand now. Okay, so in conclusion, we can say that the partial derivative of p with respect to theta equals to 2 times x transpose into y. Okay, now you can see that this value is equals to the x transposed value. Okay, so here you can see it easily how it is x transposed value. Okay, so this is our first derivative of with respect to theta. Okay, so now we are going to find the partial derivative of our other function that was here. Okay, so now we will take this function. Okay, and we are going to name it q theta, and we will once again convert it to this form or convert it in our matrix form. So this is the theta transpose value, this is x transpose, this is x, and this is theta. And then we are going to multiply each of this matrices into each other. So we are left with this and this theta vector, or sorry, theta row vector. Okay, so then we are going to multiply it with this vector. So this will give us theta 1 into this row plus theta 2 into this row, and theta n into the last row. Okay, so I think if you know matrix multiplication, then it will be very easy to understand for you. Okay, so now finding the partial derivative is same as we did in our p function. So here we have a square, so we will be left with 2 in the coefficient value. So it will give us 2 theta 1 into x11 square plus 2 theta 1 into x12 square. Okay, so moving forward to the next point, that is d upon d theta y transpose into y equals to 0. So finding the last derivation of our term. Okay, so moving ahead to find the partial derivative of this third function or the last function, that is y transpose into y. But as you can see that there is no theta value in our y function or in this dot product, and our partial derivative of y transpose into y with respect to theta will be 0. Okay, so now we can combine all of this together. So our main cost function was this, here it is, j theta, and the partial derivative of this is 0, so we just have to add these two together. Okay, so now we are going to merge it. Okay, we can see it here, and we already find the value of each of these partial derivatives. So this is here, and we can write it as the 2 theta into x transpose into x. So we will have x11 square and for each of these rows, and it is, I think, easy to understand now. Okay, so moving forward to the next part, so we will assign it a value of 0. So because we are going to find the minimum possible value of our cost function, so we are going to simplify it a bit, and the 2's got cancel out and we get this function. So this is pretty easy to understand. So now we are going to find the inverse of this function, this side, and going to multiply it with this side. So it will give us the theta value. Okay, so this is our final equation for our normal equation. So I think we finally made it, and in the next video I'm going to show you how we can actually use this function to calculate the value of slope and intercept with Python. And if you want to understand it better, then I think you should probably check out my mathematics on matrices video that I posted yesterday, or my previous video. And if you have any doubts about this, then you can mail me or you can comment in the comment section. And okay, I will see you in the next video, and thank you so much for watching. Okay.